Hello, my name is Piyush Singh and I'm an assistant professor in Tripura Institute of Technology. Now I'm going to record some lecture on this subject, digital signal processing. And in this digital signal processing, there is a one important topic, that is structure realization. And in this structure realization, we are dealing with a discrete time system. So first of all, what is discrete time system? So in this discrete time system, if any device or an algorithm that operate on a discrete time signal, that is defined as a excitation, means if our input is a discrete time signal and it produce a, if this input is passed through this particular device, or we can say it is a system, the produced output is also a discrete in nature, and that output is defined as a response of the system. So here is an example of this input and output. If we consider that this y of n is the output, or we can say response of the system, and xn is the input. So this yn is equal to 0.5 yn minus 1, and this y of n minus 1 is representing the 1 unit delay output signal. In block diagram representation, if we have a system that is a discrete time system, that is defined by this discrete time system, and we apply this x of n to this system, and the corresponding output is defined by y of n, and the input and output both are in discrete in nature. So these are the value of x of n with respect to n, and corresponding that we got some output value, and it is also a discrete value. So such type of input and output is defined as a discrete time signal, and the device or algorithm that used to operate such type to perform operation to produce output or response. This device is defined as a discrete time system. So there are some classification that we use to define the system, different type of system. So in this classification, there are static or static versus dynamic. What is a static system and what are the dynamic system? So if there is any memory element, memory means storage device are used in a particular system, so that type of device or system is defined as a dynamic system, and without memoryless system is known as a static system. And another classification is linear and versus nonlinear. It is a very important classification whenever we are going to define or realize any system. So linearity is a very important classification with respect to this system. So what is linearity? If the system is satisfy this superposition, means what is this superposition? If we have two different system, x of 1, x1 and x2n, so if these two are passes, if we have some multiplier terms a and b, and again we are going to add these two, and we pass through these added signal with some system, discrete time system, that is represented by h, and we get some output, that is y of n. We consider that y of n is the output of this type, this particular input and discrete time system. Now again we apply the same input, x1 n, and x2n, and this system h is actually similar system that we used in this first condition. These are same system. So here we multiply with a and b, and when we sum these two, the corresponding output is y defined by y dash n. If this y dash n and yn if this y dash n and yn, if these two are equal, then we can say that system is a linear. Otherwise we can define as a non-linear system. So this is the uh, additive and homogeneity property that is actually define the superposition. So it is a very important system. If system is satisfy this particular equation, means yn and y dash n are equal, the system is known as a linear system. So next is time variant and time variant invariant. It is also important classification. So in time invariant, if the characteristic of input output does not change with time, so that type of system is defined as a time invariant. Otherwise system is a time variant. In another word, if we have this x of n and the output of, if we apply x of n to a particular system, so we will get this y of n, and let's take a delay unit, k times delay unit in the input, so we will get some k times delay in the output also. So we define this y of k. So in this expression, if the take k unit delay in this first equation, k unit delay in both sides, so if we define this k n minus k, corresponding output is y n minus k. So if these this one and this one, if these two are equal, then system say that this system is a time invariant. If these two are not equal, then we can say system is a time varying system. So it is also an important property for a system, discrete time system. Next one is causal and non-causal. Causal means if the response or the output of a system is depend on only present and past input, so that type of system is defined as a causal system. Otherwise we can say system is a non-causal if there is any future input present in the response or in the output. So next is stability. Stability is also an important property, stable and unstable. So we can say if our input is bounded, then our output also should be bounded for a stable system. It means if we have any bounded input applied to a particular system and the output is also bounded, then we can say that system is a stable. Otherwise we can say the system is a not unstable. So here is an example of this stable system. So the last one is defined as the LTI. LTI means LTI system means linear time invariant. Already we have defined the linearity and time invariant. And if our system is LTI, linear time invariant, then the response of this LTI system is defined by this convolution expression. Yn is equal to summation k is equal to minus infinite to infinite xk h of n minus k. So where this h of n minus k is the delayed version of system response, and this h of n is defined as the impulse response of the system. So these are the important topic that we should know before going to realize any discrete time system.